video on conversion between mass and particles. This conversion requires two conversion factors, the molar mass and Avogadro's number. These are the equivalent. This is the equivalent for molar mass. This one is the equivalent for Avogadro's number. So when you're going from mass to particles, first you have to convert from mass to moles and then from moles to particles. And when going from particles to mass, you got to convert particles to moles and then those moles into mass using these fractions. Now, how do we know which fraction are we going to use? So when you're looking at this equivalent, you are making these two fractions from each of them. Whichever has the desired unit at the top, that's the one you're going to choose. So unit analysis method is really logical. It automatically cancels out the units that you don't need. You can review these steps of unit analysis, the dimensional analysis method, guys. Let's start with the problem. Calculate the number of hydrogen atoms in 2 grams of hydrogen. So we have to find the number of hydrogen atoms, and those hydrogen atoms are our particles. So particles can be atoms, ions, molecules, formula, unit. In this problem, our particles are atoms. But we cannot convert these particles directly, right? We have to go through we have to go from mass to moles to particles. So we need two conversion factors. So let's start out with what is given. And also, guys, when you're taking the test, when you're solving problems, you are not given this. You will not be given these equivalents. You should know those equivalents from practice and from definitions. So 1 mole of hydrogen contains how many grams? 1.01 grams. And this comes from the periodic table. All those substances, all elements on periodic table, they are all showing the mass for 1 mole of those substances. So let's start out with given 2.0 grams of hydrogen. Okay, and always put 1 at the bottom over 1 in the denominator. So this is unitless. It's not going to change anything. It is just showing that these are the fractions that you're dealing with, right? Now next one, we have to convert into moles of hydrogen. So we are going to use this fraction because this has our, so both are correct, but we have to pick this one because it has our unit that we want at the top. All right, we don't want grams, so we're going to cancel out the grams and grams. What we want is moles. Okay, now from moles, so this goes from mass to moles to particles. All right, it's not direct, it goes through moles. Now you're going to convert moles to particles, correct? So moles to particles, 1 mole is these many, 1 mole of hydrogen is these many atoms. This is again correct. This is by our definition. And since we have to find the atoms, we are going to use this fraction. It has atoms at the top. So we don't want the moles. Now we want to cancel it out. So moles and moles get cancelled. And what you need is in the numerator. Use your calculator, plug in the values. That will give you 1.192 times 10 to the power 24. Now, scientific notation is fine. However, you have to fix the significant figures. Your calculator doesn't give the significant figures, guys. All right. So here you have 2 sig figs in your given. You go by given for the sig figs in these problems. 1.2 times 10 to the power 24. Don't forget the final unit in the answer. This unit is very important. Okay. Don't forget that. All right. So let's work on this problem. Find the number of ions in 6.5 grams of copper ions. So molar mass is again given here, and if it wasn't given, then you will be using the periodic table. We're going to follow the same steps. We're going to look at the equivalent fractions. So our equivalent fractions are 1 mole of copper ion is how many grams? This many grams, and it's coming from periodic table. It's already given to you. And what else? The another factor you would need is the equivalent factor for moles and particles. So 1 mole of copper ion is 6.022 times 10 to the power 23 particles right here. So we are going to pick this one. So once again, it's the same process, mass to moles to particles. Mass to moles to particles. All right. So this is 2 moles, this is 2 particles, this has particles at the top. In this problem, our particles are ions. As I told you earlier, particles can be ions, can be formula unit, can be molecules, can be atoms. All right. Next step is you're going to start out with given. What is our given? 6.5 grams of copper ions. So right here. All right. Then you have 1 over 1. And then you're multiplying by this fraction. And then you're multiplying by this fraction. And as you do that, you keep cancelling the units that you don't need. So let's do that. This one, we don't want that. This one and this one, no. In our final answer, what do we want? We want the number of ions. And they are right here. Now use your calculator. This will give you 6.1594 times 10 to power 22. So here, don't forget to write the units, and you have to round off here because it is 2 sig figs. So final answer will be 6.2 times 10 power 22 ions. So if you were to explain in writing, how would you determine the number of particles from the given mass of the sample? You would say, to convert from mass to particles, I will be using 2 conversion factors. And what are those conversion factors? The molar mass and the Avogadro's numbers. So what are you going to do? You're going to say, I would multiply the given mass, because this is gram, the given mass by inverse of molar mass, and then again multiply by the Avogadro's number. All right, let's go to the next problem. In this problem, we are going from particles to mass, but again, we can't go directly, so we have to go through moles. Find the number of 1.95 times 10 to power mass of 1.95 times 10 to power 23 atoms of carbon. So here you have to find the mass. Again, we can't find the mass directly. Okay, we have to go through moles. Moles are very important, guys. So no matter how you work, you always go through moles. You always come back to moles. So since we have to find mass, we also need to find the moles before that. This is already coming from the definition, and the molar mass is given. This is coming from definition that 1 mole of carbon contains these many particles. So which fraction are we going to use now? Since you need the moles, you're going particles to moles to mass. We need moles, so we're going to use this fraction, moles at the top, okay? And then it is saying you have to go to mass. So mass is grams here. This is mole at the top, grams. The desired unit at the top, the starting unit at the bottom. All right, let's start out with given 1.95 times 10 to power 23 atoms of carbon times, we don't want this, so we're going to cancel them. We have used multiply by this fraction, cancel atoms, and these many atoms in 1 mole of carbon. Now the next fraction is this one. We don't want moles in our answer, so we're going to cancel, because in our answer, what do we want? We want the mass in grams. We want this one, grams. All right, so these are all the ratios, these conversion factors. Now use your calculator and solve it. You're going to get 3.888, and this 23. These cancels because these are the powers numerator denominators. You can just subtract them. And 1, 2, 3. So you're going to round off here. This will give you 3.89 grams of carbon. Unit, once again, guys, for measurement, you always have to have a unit and the number, both. So without unit, that number won't mean anything. What is the mass of 2.2 times 10 to power 29 molecules of methane? So this one, correct, because this is coming from the definition. These are the fractions. Again, you're going to decide which fraction you're going to use. Now, since you're finding the mass, and what are you given? You're given the particles. So you're going from particles to moles to mass. Okay, particles to moles to mass. All right. So since we have to go from particles to moles, we are going to use this fraction. Okay, and then from after moles, we have to go to mass, which is grams. We are going to use this fraction. The desirable unit always at the top. Okay, start out with given 2.2 10 to power, this one, 29 molecules. This time my particles are molecules. Okay, and these are molecules of methane, CH4. And don't forget to divide by 1. And this is unitless once again, so it's not affecting anything, but you just put it here. It shows that you're dealing with the fractions. We don't want molecules in our answer. This is the fraction we have picked. 10 to power 23 molecules of methane. Okay, in 1 mole of methane. Cancel this and this. Now next we have to go to mass. Grams at the top. We don't want mole. 1 mole CH4, 16.05 grams CH4. Cancel this and this. Now use your calculator. You're going to get 5.863 times 10 to power 6. All right, so 1, 2, 2 sig figs. So you're going to round up at this place. This will give you 5.9 times 10 to power 6 grams of methane unit. All right. Okay, so if you were to explain in writing, you would say to convert from particles to mass, I will use 2 conversion factors. And what are those 2 conversion factors? This one, the Avogadro's number and the molar mass. So what are the steps? What did you do? You multiplied the given number of particles by inverse of Avogadro's number, and then you multiplied by the molar mass of the substance. Alright guys, now I want you to try this problem, both of these problems, and I'm giving you the answers. For the first one the answer is here, and for the second one the answer is here. You have to come up with the equivalent fraction. Pause the video, try yourself. Okay, here you go. Just check your answer. Check all the steps. Did you follow all the steps? Okay guys, I hope the video was helpful. One last thing. If you would like to use, you can use mole math if you want to. However, I tell my students all the time, just use unit analysis method. Okay? Alright, thank you for watching. Hope the video was helpful.